It's the notes for AP Calculus on the topic of advanced tangent line problems. So let's first recall the three forms of linear equations. The one we traditionally use for tangent line problems is point-slope form. That tends to be the easiest to start with. So remember, we've also got slope-intercept form, the one that's easiest to graph from, where m is the slope and b is the y-intercept. And then there's standard form, where the x and y's are on the left and the constant is on the right. So in standard form, also note that coefficients A, B, and C are integers. Remember what integers are, numbers like -3, -2, -1, 0, 1, 2, 3, and so on. In other words, numbers that don't have fractional or decimal parts to them. So traditional tangent line problems give you the function, give you the x-coordinate of the point of tangency, so all you have to do is plug in the x-coordinate to find the point of tangency, find the derivative, and plug in the x-coordinate to find the slope. So what we're looking at today is some non-traditional ways they could ask you things that involve the tangent line. So, first example says if the line tangent to the graph of the function at the point 3, -5, so is tangent to the graph at this point, and that means this point is our point of tangency, 3, -5. It passes through the point -1,8, then f prime of 3 is, so f prime of 3, notice that's the same x-coordinate as our point of tangency. So that represents the slope of the tangent line. So that's what we're asked to find, really, the slope of the tangent line. However, we don't have the function, so we can't just take the derivative and plug in 3 like you normally do. So instead, we have to find the slope of an alternate way. And the way to do that is using the fact that we have another point on the tangent line besides the point of tangency. And just going back to algebra way of finding the slope between 2 points. Remember the slope formula is the difference of the y's, so -5 minus 8 over the difference of the x's, 3 minus -1 gives you -13 over 4. So that represents the slope of the tangent line, and that's what f prime of 3 also represents. So that means f prime of 3 equals -13 over 4. Okay, let's take a look at another example here. This one says determine the equation of the line tangent to the graph. So again, we want the equation of the tangent line, g of x, at the point where g prime of x equals -1/2. So this time, rather than asking us to find the slope of the tangent line, they give us the slope. They tell us the derivative equals -1/2 at that point of tangency. So there is the slope of our tangent line, -1/2. And we're asked to write the answer in slope-intercept form. So in other words, y equals mx plus b. We're all done. So here we have the slope of the tangent line, but in order to write the equation, we also need a point on that line. And the easiest point usually to find is the point of tangency. So what we can do is first, let's rewrite our function here, g of x cube root to the second power, the same as raising it to the 2/3 power. And then we've got 3x minus 2. So since we know the derivative has to equal -1/2, let's go ahead and take the derivative of that. So g prime of x, using the power on the outside, that would be 2/3 3x minus 2 to the -1/3, and subtract 1 from the exponent. But there's a function inside, so you also have to use the chain rule there. Take the derivative of 3x minus 2, it is 3. We'll divide by that derivative. And let's go ahead and simplify that. See the 3's reduced out. So all that's left on the numerator then is 2 over, bring that to the non-Euclidean radical form, would be the cube root 3x minus 2. And we set that equal to, we want it equal negative 1/2. And this gives an equation that could solve for x, in other words, the x coordinate of our point of change. We make the derivative negative 1/2. So we have the slope of the tangent line being negative 1/2. So the easiest way to solve this one probably is you have two fractions equal to each other, it's by cross multiplying, and you can treat this negative as part of the numerator or denominator, and treat it as part of the denominator. That way we can just multiply 1 times the cube root of 3x minus 2 gives you the cube root of 3x minus 2 equals negative 2 times 2, negative 4. And then the reverse of cube rooting something is cubing it, so raise it to the third power, and balance it out, raise the other side to the third power. We get 3x minus 2 equals negative 4 cubed, that is negative 64. Add the 2, you do 3x equals negative 62. So x would equal negative 62 over 3. So there's the x coordinate of our point of change. Next, we need the y coordinate of our point of change. So now we just take that and substitute it back in to the original equation. Get the y coordinate. So I'll do that right here. So we have g of negative 62 over 3 equals the cube root of 3 times negative 62 over 3 minus 2 squared. So when you simplify that, you can see the 3's reduced out. Gives you negative 62 minus 2 is negative 64. So the cube root of negative 64 squared. Cube root of negative 64 is negative 4. Negative 4 squared gives you 16. So there's our y coordinate of our point of change. So now we know the point of change is negative 62 over 3. That's 16. So now we can write our tangent line. So even though it says to write in slope-intercept form, I think it's probably easiest to still start in point-slope form and then get it into slope-intercept. So using point-slope form, we can have y minus the y coordinate. Our point of change to is 16. Sorry, we have to write down this as the point of tangency. Equals the slope we knew from the very beginning was negative 1/2 times x minus the x coordinate, negative 62 over 3 makes it plus 62 over 3. So that's in, if it didn't specify the form, we could stop right there, just apply the tangent. But because we wanted the slope-intercept form, first you can get rid of the parentheses by distributing out the negative 1/2. You get y minus 16 equals negative 1/2 x. You distribute that, it's negative. 2 goes into 62 31 times, so 31 over 3. And then to get in slope-intercept form, we want the y by itself. Just add 16, which is the same as adding 48 over 3. So you have y equals negative 1/2 x, 48 over 3 minus 31 over 3, that's 17 over 3. So there's our tangent line slope-intercept form. Alright, so take a look at the next one. This one says, in the xy plane, the line 2x plus y equals k, where k is a constant, is tangent to the graph y equals x squared plus 4x plus 5. So here, this is the tangent line already. The only thing we don't know is what that constant of k is. That's what we're trying to find. What's the value of k? So since we know that's a tangent line, well, we can find the slope of it probably by putting it in slope-intercept form by subtracting the 2x. So we know the slope we can see is negative 2. So if the slope of the tangent line is negative 2, that would mean the derivative of this has to equal negative 2. So if we take the derivative, dy dx would be 2x plus 4. Set that equal to negative 2. Again, that will allow us to find our point of tangency, or the x point of the point of tangency. So if we subtract the 4, you get negative 6. So we get x equals negative 3. So there's the x point of our point of tangency, and then let's substitute that in right there to find the y point. So y would equal negative 3 squared plus 4 times negative 3 plus 5. So negative 3 squared is 9, minus 12 plus 5. Gives you 14 minus 12 is 2. So there's our y coordinate. So, negative 3, 2 is our point of tangency. And notice we can use that to help us find k. Now we can plug that into the tangent line equation for x and y, and that allows us to find k. So technically, any point on the tangent line would allow us to figure out what k is, but the easiest one to find is our point of tangency. If we do that, we'll get 2 times x is negative 3, plus y is 2, is k. So negative 6 plus 2 is k. So k would equal negative 3. The next example says, let f be the function given by f of x equals x squared plus 5x minus 7, and let g be the function given by g of x equals 4 over x. At what value or values of x do the graphs of f and g have perpendicular tangent lines? So, first remember what we know about perpendicular lines, in this case perpendicular tangent lines. We know their slopes are opposite reciprocals. So, to get the slopes of these, well, there's 2 different functions, we need the derivatives, right? So let's first take the derivative of f of x. That'd be 2x plus 5. And then, before we take the derivative of g of x, notice, if you leave it as 4 over x, you'd have to use the quotient rule. So to avoid using the quotient rule, you can write it as 4, bring that up to the numerator, becomes x to the negative 1. And then you just use the power rule. And then g prime of x would be negative 4x to the negative 2. Which if you simplify that, it's negative 4 over x. So these represent the slope or derivatives of each function. And we want them to be opposite reciprocals. So let's pretend, for instance, if this was a problem that said parallel tangent lines. Well, if they were parallel, we'd want the slopes to be the same, so you would just set 2x plus 5 equal to negative 4 over x squared and solve for x. But if we want to be perpendicular, we don't want to be equal, we want one to equal the opposite reciprocal of the other one. So think about which of these do you think would be easier to take the opposite reciprocal of? And this is already a fraction, it's probably easiest to take the opposite reciprocal of this one. So if we do that, the opposite reciprocal of that one would be x squared over 4. The reciprocal I made positive equals, that way the slope of f equals the opposite reciprocal of the slope of g. And then to solve it, you want to wipe out the fraction, just multiply everything by 4. 8x plus 5 equals x. Sorry, 8x plus 20 equals x squared. If the x squared is already positive there, it's probably easiest to get the left side equals 0. Subtract the 8x and subtract the 20. And then you can factor that. X minus 10, x plus 2. So we get x equals 10, x equals negative 2, so those each equal 0. So there's two answers. That's why I said with the value or values. So x could either equal negative 2 or it could equal 10. Two possibilities. Sometimes it might only be one, sometimes more than two. That's what's possible. And it only asks for the values of x here, so that's all we need. The next example says, let f be the function given by f of x equals 3x squared plus 2x minus 4. Find the equation of the tangent line that's parallel to the secant line of the interval. So just remember what that is here. The secant line represents a line that goes between 2 points. So there's our function f. 2 points, in this case it's negative 1 and 2. That would be the secant line. What we're looking for is a tangent line that's parallel to that. So in this case it looks like it'd be about right there. So before we can make it parallel to it, remember parallel lines we know have the same slope. Well, in order to make it the same slope, we first need the slope of the secant line. So it's on this interval that's giving us the x-coordinates. And then to find the y-coordinates, since they're points on the function, we can just plug those one at a time into f. So f of negative 1. 3 times negative 1 squared plus 2 times negative 1 minus 4. I'll give you 3 minus 2 minus 4 is negative 3. So there's the y-coordinate of that point. The base of that point is the point negative 1, 3. And the other one would be f of 2. 3 times 2 squared plus 2 times 2 minus 4 would equal, for 2 squared is 4 times 3 is 12, 2 times 2 is 4 minus 4, so the 4's cancel out, giving you 1. So the other point on the secant line, first the function is 2. So now we can find the slope of the secant line. Again, the slope formula between 2 points. Difference of the y, so 3 minus 12 over the difference of the x's. Negative 1 minus 2. That gives you negative 9 over negative 3, which is 3. So that's the slope of the secant line, and we want it to be parallel to that. So we want the tangent line to be at the same slope. So this is the slope of the tangent line as well. So now we can take the derivative of our function here, which gives us the slope. Of x is 6x plus 2. And now we know that we want that to be equal to 3. So we can set it equal to 3. So if you subtract the 2, you get 1, 6x, divided by 6. So you get x equals 1/6. There's the x part of our point of KFC. Oops, I just realized I made a careless mistake there. Just fix that here. This was negative 3. Actually, I wrote down a positive 3 there. So I was a negative 3 minus 12 is actually negative 15. Divided by negative 3 is actually 5. So 5 is what I should have said that equal to. That means when you subtract 2 from 5, you get 3. Divided by 6, so x actually equals 1x. Not 1/6. Sorry about that. So now to find the y coordinate, we just plug it back in the original equation. Correct? So alpha of 1/2 is 3 times 1/2 squared. That's 2 times 1/2 minus 1/2 squared is 1/4, so times 3 would be 3/4. These cancel, so just 1 minus 4 is negative 3. 3/4 minus 3 is the same as 12/4, which gives you negative 9/4. So now we know that 1/2 negative 9/4 is our point of tangent. And now we can write our tangent line. Notice on this one it says to write it in standard form. AX plus BY equals C. But again, it's probably easiest to start in point slope form. So let's do that. For the tangent line, you do y minus the y coordinate, which is negative 9/4, plus 9/4, equals the slope, which was 5, times x minus the x coordinate, was 1. So then again, in that standard form, first we distribute the 5, over to the parentheses. We have y plus 9/4 plus 5x minus 5/2. And then we want, on standard form, we want the x's and y's on the left and the constant term on the right. So I'm going to subtract the 5x and subtract the 9/4. Do that, you get negative 5x plus y equals, well, negative 5/2 is the same as negative 10/4. Minus 9/4 is negative 18/4. And the last thing to remember in standard form, a, b, and c are integers. So to wipe out the fraction, I just multiply everything by 4. So I give us negative 20x plus 4y equals, there the 4's cancel out, negative 19. And then just keep in mind in standard form, sometimes they'll make the coefficient of the x term positive, so you can multiply out by negative 1. You could write it as 20x minus 4y equals 19. You can also do that. And that concludes the notes for AP Calculus on the topic of advanced tangent line problems.